Assalamualaikum and good morning everyone. Today we are going to continue our lesson on the formation of tissue fluid and lymph, right? Okay, I'm sure all of you are very familiar with this diagram here, okay, which shows you how the arterial end of arteries are being connected with the venule end of the vein by the blood capillary, okay, and between this arterial end and venule end, you can see there are many body cells here, right? And between these body cells, there are these empty spaces, which is filled with interstitial fluid or tissue fluid. Okay, then you can see these arrows here. It shows you the movement of the fluid, which is from your blood capillary into the lymphatic capillary. Right? Now you're going to learn in detail. Actually, the fluid, okay, from the arterial end is being filtered into the um, between these body cells, which forms the interstitial fluid, and then this interstitial fluid will diffuse into the lymphatic capillaries and eventually form the lymph, right? Okay, now this arterial end, okay, has high hydrostatic pressure as well as high solid potential because of the water and solids in the blood. Okay, now roughly arterial end, okay, has net pressure around 1.95 kilopascal. Okay, the tissue fluid outside the blood capillary, okay, has lower hydrostatic pressure and lower solid potential. Okay, and then the tissue fluid net pressure is about positive 0.26 kilopascal. Again, let me rephrase. This is where the tissue fluid can be found. And this tissue fluid also known as interstitial fluid. Okay, so the difference in pressure between the arterial end and the tissue fluid, right, will result in outward flow or filtration of fluid, okay, via diffusion from the blood capillary into the tissue fluid. Okay, so you can picture how this fluid is being filtered from this arterial end into this tissue fluid. Okay, and the fluid, when it already diffused into this tissue fluid, okay, the fluid from the arterial end became the tissue fluid itself or interstitial fluid. Okay, now what are the contents of this fluid that is being filtered from the arterial end? Okay, so this fluid consists of water, digested foods, waste products, hormones, and leukocytes. Now, when we talk about leukocytes, okay, this except, okay, all the other leukocytes except erythrocytes and platelets. Okay, now as well as some proteins. Okay, so to recap, the net pressure of arterial end, we have positive 1.95 kilopascal, while the net pressure of tissue fluid is positive 0.26 kilopascal. So there is a filtration of fluid, okay, and the filtration of fluid is by diffusion. Now the net pressure in the tissue fluid, okay, then increases, yes, because they are diffusion of fluids from the arterial end into the tissue fluid. So eventually the net pressure in the tissue fluid will build up and increases. Now this will cause some of the tissue fluid to diffuse into the lymphatic capillaries. So the tissue fluid that entered the lymphatic capillaries is known as the lymph. Now there are some tissue fluid that remains, okay, and then this remaining tissue fluid outside the blood capillaries, okay, will have net pressure of positive 0.26 kilopascal. the pressure doesn't change, although some of the tissue fluid already diffused into the lymphatic capillaries. Now, this remaining tissue fluid, okay, still has the same net pressure, okay, and then this net pressure of the remaining tissue fluid, which is positive 0.26 kilopascal, is higher than the net pressure in the venule, which is negative 0.39 kilopascal. So this will cause an inward pressure of positive 0.65 kilopascal, okay, pushing the remaining tissue fluids, or you can say filtration, okay, the remaining fluids into the blood capillaries at the venule end via diffusion. So to recap, okay, we have net pressure of tissue fluid, which is positive 0.26 kilopascal, and the net pressure of the venule end, which is negative 0.39 kilopascal, and the sum of these two net pressure, okay, will give you a value of positive 0.65 kilopascal, and this will cause reabsorption of fluids, okay, from the tissue fluid into the venule end. Okay, so now there are two processes here: filtration and reabsorption. Okay, summary on the movement, okay, of this fluid, okay, this fluid came from the blood capillaries, which has the highest net pressure, right? And then this fluid will diffuse into the tissue fluid, and then it became the tissue fluid itself, or interstitial fluid. And this interstitial fluid will be filtered, okay, into the lymph capillaries, okay, via diffusion. Okay, so this lymph, okay, will be channeled through the lymph veins, lymph ducts, and eventually to the large circulatory veins, which we have learned already. Okay, and apparently this vein has the lowest pressure. Okay, calculation terms to be considered involving formation of tissue fluid and lymph. Okay, so the net pressure, which I have mentioned beforehand, okay, so apparently it is the pressure that drives the fluids across the capillaries. And this net pressure can be calculated by force moving the fluids out from the capillaries minus the force moving the fluids back into the capillaries. Okay, or we can rewrite that as blood capillary hydrostatic pressure, okay, plus with interstitial fluid colloids osmotic pressure, or interstitial fluid osmotic pressure, right, minus with the sum of blood plasma colloids osmotic pressure, or blood plasma osmotic pressure, okay, plus with the interstitial fluid hydrostatic pressure, right? So if we found this quite difficult to remember, okay, we can simply rewrite the formula into BHP, which is blood hydrostatic pressure, plus with interstitial fluid osmotic pressure, minus with, okay, blood colloid osmotic pressure, or blood osmotic pressure, plus with interstitial fluid, okay, hydrostatic pressure. Or you can simply rearrange again into this formula, okay, which is hydrostatic pressure of blood minus with hydrostatic pressure of interstitial fluid, okay, minus osmotic pressure of blood minus osmotic pressure of interstitial fluid. So depends on you which formula you want to use. Okay, apparently they are the same. Now, osmotic pressure, okay, is the minimum pressure which needs to be applied to a solution to prevent the inward flow of its pure solvent across a semi-permeable membrane, okay, or simply osmotic pressure can be defined as measurement of the tendency of a solution to take in pure solvent by osmosis. Right. Hydrostatic pressure is the pressure exerted by any fluid in a confined space. Okay, that is hydrostatic pressure. A positive value of net pressure indicates that a net outward pressure from the arterial end. So this promotes filtration of tissue fluid via diffusion. Okay. Then a negative value of net pressure indicates a net inward pressure to the venial end. So this promotes reabsorption of fluid into the capillary, okay, or blood capillary via diffusion. Okay, remember, students, I stress out the word diffusion here. Okay, so we have this one diagram here, right, to show you how the formula can be applied. Right, so we have this blood capillary which has arterial end and this venial end. So let's apply to the formula. Yes, the formula that I've mentioned earlier. Right. So now we are going to see the calculation is based um, on the arterial end as well as the venous end. Right. So the formula that I mentioned earlier, BHP plus IFOP, okay, minus the BCOP plus with IFHP. Okay, so now let's do the calculation at the arterial end first. All right, so the net filtration pressure, right? Because why is it net filtration pressure? Because at the arterial end, the pressure is higher. So this obviously promotes filtration. Okay, so a better way how you can um, mention the name of this pressure at the arterial end is net filtration pressure. Okay, and at the venous end, okay, you know already there is a reabsorption of fluid. So at the venous end, it will be known as net reabsorption pressure. Okay, so now let's start with calculation at the arterial end. Okay, so the net filtration pressure equals to blood hydrostatic pressure. You can see here the blood hydrostatic pressure, which is 35 millimeter mercury. So 35 plus with the interstitial fluid osmotic pressure. So it's already given to you here. Okay, interstitial fluid osmotic pressure, which is 1. So 35 plus 1 minus with, okay, blood colloid osmotic pressure. Again, it's given here already. Blood colloid osmotic pressure, which is 26. 26 plus with interstitial fluid hydrostatic pressure. Now, interstitial fluid hydrostatic pressure, okay, it is 0, right? And interstitial fluid hydrostatic pressure is always equals to 0 unless stated otherwise. Okay, so 26 plus 0. So the sum of this will give you 10 millimeter mercury, which is a positive value of a net pressure. When positive value, when you do your calculation and then you get a positive value of a net calculation, net pressure, so meaning to say filtration occurs. Okay, now let's look at the venous end. Okay, so the pressure at the venous end, okay, BHP, blood hydrostatic pressure, which is already given here 16, right, plus interstitial fluid osmotic pressure, which is already given here, okay, which is 1, okay, interstitial fluid osmotic pressure, minus with blood colloid osmotic pressure, which is 26, okay, plus with interstitial fluid hydrostatic pressure, which is 0, okay, so plus 0. And then the sum of this calculation will give you a value of negative 9 millimeter mercury. So a negative value indicates that there is a reabsorption of fluid. Okay, now there's some calculation here. Okay, so student, you try to test your knowledge, okay, by applying the formula that I mentioned earlier. Okay, so given hydrostatic pressure and osmotic pressure at arterial end are 35 mm mercury and 28 mm mercury respectively, while at the venial end are 20 mm mercury and 28 mm mercury. If the osmotic pressure of the tissue fluid is 3 mm mercury and the hydrostatic pressure of the tissue fluid is 0 mm mercury, calculate the net pressure that caused the fluid to move out from the arterial end. So, meaning to say your calculation must resulted in a positive value. Right, filtration must occur here because in the question itself it mentioned fluid to move out from the arterial end. Right, so you pause this video and do your calculation now. Okay, give you 2 minutes. Tick tock, tick tock, tick tock. All right, done. 2 minutes. Wow, that came so fast. So now let's check your calculation here. If you haven't do, please do it now. All right, then you check. Okay, if you have done, good. So net pressure at the arterial end, okay, equals to, all right, this was the given formula. Okay, so it's best if you can memorize this formula or understand it better. So we have 35 plus 3 minus 28 plus 0, and eventually you get 10 millimeter mercury. Right? Did you get that correct? Okay, good. Congratulations. If you got it correct, means you understood. All right. Next question. Okay, so you pause this video, then you come back after 2 or 3 minutes. Done. All right. The question says, describe what occurs at the arterial end. All right. Now, so before you can describe what occurs at the arterial end, you need to calculate the net pressure at the arterial end first. So the net pressure at the arterial end, all right, we give you 13 millimeter mercury. So what occurs at the arterial end? So again, like what I mentioned earlier, a positive value of the net pressure indicates a net outward pressure from the arterial end, thus promoting filtration of tissue fluid via diffusion. Right? Okay, next question. Okay, calculate the net pressure at the venial end and describe what occurs at the venial end. Right? Pause the video and do the exercises now. Done. All right. So the net pressure at the venial end will result in negative 9 millimeter mercury. Okay, which indicates a negative value of net pressure indicates a net inward pressure to the venial end, thus promoting reabsorption of fluid into the capillary via diffusion. All right. Okay. The last question. What is the net pressure that causes fluid to be filtered out from the arterial end? All right. Done. Calculation. Okay, so the net pressure that forces the fluid out of the capillary, okay, we give you a value of positive 12 millimeter mercury. All right, so that's it. So I guess that's the end of today's lesson. All right. Okay, see you again in our next lesson. Bye.